Skip over that. She introduced me. I've been at Anaconda since 2015, and I've been building packages most of that time, and it's been a learning curve. And thank you guys for using what we've produced. What I want to talk about today is Conda highlights from the past year, the State of the Union, which is specifically the community, because Conda is part of a really large ecosystem, and it's on its own. It's not nearly as much as it is with that community. And a little bit of a preview of what you'll see in the very near future and a little bit further out. So let's talk about what we did in the past year. The major things that we did were to improve the user experience with something called Conda init. I'll tell you more about that. We've improved interoperability with pip a little bit, and we've also spent a lot of time trying to speed stuff up. And I'll talk a little bit about why stuff might go slow, how you can figure out what goes slow, and what we're doing to work on that. So why did we spend time on Conda init? And the reason is because a lot of people get hung up on this core concept of path. It's how your OS finds what program to run. And every OS has this, but on Windows it's especially devilish because path is also used to load libraries. And this has huge implications for whether stuff works or not. So what do you do with path? Do you put your Conda environment first? If you do that, other stuff breaks, like guaranteed. If you put Conda env last, the Conda env stuff doesn't work. And so a lot of our support issues are just like dumb stuff with path. Furthermore, path alone is sometimes not enough to make things work. Sometimes you need extra things set. So there is this concept of activation of environments. It's been around a long time. When you activate an environment, what we do is we put our path first, and because it's an explicit thing that you do, it doesn't interfere with the rest of your system stuff in the same way that modifying path globally might. The other thing that we do is we run scripts that packages can provide to set other environment variables, like Java Home might be necessary for your packages to run. So the absolute ideal that we want to provide for people is we want to encourage everybody to activate their Conda envs, but only when they need to use them. We want to keep only Conda, not all of the Conda environment, on path all the time, but make it trivially easy for people to activate their Conda environments whenever they want to use it. So how do you activate? Up until, I guess, relatively recently, there were two different ways. On Windows, you did activate, and on Linux and Mac, you did source. And this was a source of a lot of confusion. Why is there this difference? It's basically down to how shells work. And we kind of didn't like that. We wanted one single way to do it. And so we did add this new shell function, Conda activate. This replaces those other two, and now you can just tell everybody to do it the same way. This has been around a while. We added this in Conda 4.4, but the setup for it wasn't all that easy. So long story short, this is what Conda init is for. Conda init is to make this part easy, to get all this Conda activate stuff working well, and also to support more shells better. So up until Conda 4.6, we really only supported cmd.exe and bash, and other stuff might work. But we've done a lot of work to make stuff work better in more different shells. As for Windows, people have been asking for PowerShell support. We finally added that in the past year. We also added the equivalent to the Anaconda prompt you guys may have used, just the Anaconda PowerShell prompt. This doesn't require you to modify your system at all. You just run it, and it activates the environment and gets you where you want to go. This is a feature that you may not be familiar with, but we actually have a package that installs this shortcut. And you can install this package into any environment, and you get a shortcut that drops you into that environment activated. So it's kind of a cute, nice tool you can use in arbitrary environments. The same is true for the Anaconda prompt, which is the batch, the cmd.exe thing, Conda install console shortcut. So give that a shot. I find it very, very useful. So Conda and pip, who's been burned by using pip in a Conda environment? Yeah, it's kind of hairy, and it's hairy because pip didn't and doesn't respect the Conda metadata like all the dependency information that says what stuff should be there. And Conda really didn't do a good job of saying something's already being provided by pip, so you don't have to use Conda to do it. So in 4.6, we've done quite a bit of work to try to get this to work better. The solver can consider pip-installed packages as part of the solution. The solver may also be able to remove pip packages and replace them with Conda dependencies. Unfortunately, we really wanted this to go into 4.6.0 by default. It's actually very, very costly for Conda to be parsing all of pip's metadata. And so we had to disable this by default, but we certainly encourage you to try it and give us feedback if you like using it. So there's quite a bit of work left to do on Conda-pip interop. One of the key things is resolving namespace conflicts. And so what a package is called in the Conda world may not equal what it's called in the pip world. So we have to have kind of like a lookup table to make those line up in some way. Pip has this notion of markers where you may have seen like the square brackets, and they use that to install extra stuff. So one example would be matplotlib, kind of by default does not depend on Qt, but it could if you wanted to use Qt for your displays. And then obviously, clearly, we want to do the performance optimization so that we can have this turned on by default all the time. So let's talk about speed, because everybody is talking about speed these days. What exactly is Conda doing when you're sitting there waiting for a spinner? There's a lot of different phases to a Conda installation, and so each of these kind of vertical levels is what I'll call a phase. The fetching and the loading of the repo data is one phase. The reducing the index is what happens after that. It takes your specs and kind of reduces the problem size so that SAT doesn't have as much work to do. Then you do SAT, and finally you install all your packages. People blame the solver for a lot, and it's easy because it's a kind of a black box, but there's a lot to SAT that I think people don't understand yet, and so we've tried to explain that in this blog post that I encourage you to go read. But suffice to say, when you talk about Conda's solver, it's really more accurate to say you're talking about Conda's optimizer. You don't want simply satisfiability. You want an optimal solution, right? And so there's a lot more details to that, and there's a lot of careful consideration that goes into how to formulate the problem and what to prioritize in what order to give you the solution that you want, rather than just simply a solution. So what's the slow part? The answer is, I don't know, right? It could be a lot of stuff, and it very much depends on your situation. So are you creating a new environment, or are you installing into an existing one? If you're installing into an existing one, you have all of your existing constraints to consider, and that can make the problem harder, actually, than creating a new one. If you have any pip installed dependencies, and you're using this Conda-pip interop stuff, that plays a major role. What channels are you using? If you're using really large channels, that has an effect on slowing things down. The other thing about channels is they're all different sources of metadata, and metadata is of varying quality. And so we'll talk a little bit later about what kind of metadata can trip up Conda. That's certainly like a consideration in what channel you're using. And finally, what packages are you using? Because what specs you provide determine how Conda behaves with those like initial trimming steps and all that stuff. It very much affects the problem. So how do you see what Conda step is slow? This is part of what's been added to Conda 4.6, I believe. You can set this particular environment variable, and Conda will start dumping timing information out to a file on your computer. And so you can see over here on the left, these are the different functions that are being called along the way. And on the right, you see how much time they took. So this is a really great way to understand like your particular use case. And if you want to report that something's slow and you think we could do a better job optimizing it, this kind of information is incredibly valuable to us. So what are the bottlenecks that we think are common? For quick installs these days, it really comes down to a mix of a number of things that really depends on what packages you're using. So for very large packages, say MKL or PyTorch, things in the hundreds of megabytes, downloading and extracting the files can take a long time, right? On the order of a minute or something like that or more. The verification checks are things that we've added to make sure that Conda does sane things. So these are things like, are the files in the tarball all what they should be? And so this helps identify when data corruption has happened, and that's the reason you're broken. These are things you can disable. There are configuration options for it if you just want to go fast. Repo data download and reading up certainly always takes time. Reducing the index takes time, and we'll talk more about how to speed that up. Whenever Conda is taking more than like some small number of minutes, like you get into hours, it's almost certainly something gone wrong with the metadata. And so these are issues where we certainly want to hear from you about it, but the answer is probably going to be, let's identify what metadata is bad here, what's allowing things to go get confused, and let's fix that metadata. So reducing the index is one thing that we dramatically improved pretty recently. And the way that reducing the index works is you start out with your index and your specs, and you say, okay, for this spec, let me pull in all the packages that apply, that match that spec. And you do that for all your different specs. And then you take the dependencies of those packages from your explicit specs, and you pull all of those in. So it's this recursive tree that you kind of build up this smaller index from. And that's what you end up feeding to the solver. Now, one thing you can do to make things go faster is to just make your spec a little bit more specific. And so if you go from the last slide to this one, you'll notice that I've just changed my spec to be Python equals 3.7, and you're going to cut out a lot of different packages that way. So that's something you can do to make things go faster. Something that we did to make things go faster is when you have an explicit spec, you look at the dependencies of that spec, the ones that it pulls in, and you don't let things go any broader. So what I mean by broader is this spec is an exact spec. It is to say it has the version number and the build string. It matches only one thing. And what we implemented is a rule that says Conda is not allowed to pull in any dependencies that would broaden from an explicit spec. It's not to say that it can only bring in that one package. It's to say that anything else also has to be an exact spec. And so this dramatically sped up creating environments with the Anaconda meta package. So what it does is it just dramatically simplifies the problem that gets fed into the solver. And it also has the net effect of preferring the newer stuff that has more correct constraints. So here, I don't know if you could probably read that. We've got the index package size. I had to scale this so it would line up with the seconds. So we've got 12,985 packages in the reduced index generated in version 4.5.11, and that went down to 7,067 packages just by making this constraint change, by requiring that things not get broader. You can see that the solve time dropped a lot from doing that. So it's definitely a good thing, but I guess what I would point out is that if you manually do your specs, that's the best possible world. So you're trading like flexibility for speed is what you're doing. And the more you can pin stuff down, the faster things go. And that's been true for a long time. We haven't changed anything with regards to that. It's the same. So I think one thing that the BioConda community has actually recommended, they've seen this, and what they do is they build their environment files, and then they pin them exactly, and they distribute those environment files. So they're making people just kind of use something that's really already solved. You pay that solving cost once, and you pass it along. But Conda's taking hours. Yeah. We see this when Conda gets really confused and it tries to go reach into really old metadata or tries to like flip packages between channels a lot. There is this new setting in Conda 4.6 called channel priority. It used to be just true or false, but now we've actually got this new mode called strict. And what strict does, ordinarily you kind of consider all the channels from all the packages, and yeah, they have priority, but you're free to reach from one channel into another to satisfy a dependency. And so if you've got really loose dependencies on old packages, per se, those can get pulled in, and that's where things get confused, and those things that were under constrained usually are just broken. So what strict channel priority does is it ignores those. And the way that it does this is it just says, okay, I have my top priority channel here, say Conda-forge. For stuff that has the same name on defaults, just ignore it. And this is like a really brute force thing, but Philippe will attest, Conda-forge guy who does a lot of environment management with the geospatial stack, which is notoriously difficult. This simplifies a lot of problems because it's just sort of like saying, I know that my package ecosystem, my channel, is self-consistent, and I'm going to keep it that way. And I'm still free to go get stuff from defaults, but it's only stuff that I don't provide. So we've seen a lot of very good progress from this, and we'll talk more about this in a little bit. For now, I want to switch to talking about the community a bit. And a lot of the community centers around Conda-forge. Conda-forge is very quickly becoming, or has become, the de facto community center for building Conda packages. And I think one of the reasons why that's true is because they have developed this, they call it the auto-tick bot. And the auto-tick bot just simplifies and greatly reduces the amount of work that's necessary to maintain packages. Conda-forge also this year adopted Conda-build 3 and our Anaconda compilers. We'll talk a tiny bit more about that. There's a new project called Conda metachannel that aims to reduce the size of the repo data that Conda-forge produces. Because Conda-forge has gotten so big, it's actually causing a lot of problems with the slowness for people, but metachannel helps. Conda-forge has gotten quite a bit bigger. We're starting to put arbitrary community channels behind our Cloudflare CDN. And so what this does is it gives you much greater bandwidth all around the world. And it also takes the load off of anaconda.org so that we can have fewer errors for you guys. And finally, Conda-forge is starting to work on Power8 and AArch64 support. So the bot, if you guys have been on Conda-forge, or use Conda-forge and you appreciate having up-to-date software, you can thank the bot for it, largely. What the bot does is it monitors different software sources that you define in your recipe, your meta.yaml. And when there's a new release, the bot will submit a PR for you to automatically, the PR triggers the rest of Conda-forge's machinery to build the packages, and it reduces the maintenance load on a feedstock maintainer to just like clicking merge. So this thing has been huge for helping us build a maintainable system, especially when so much of our software is sort of like a repackaging from somewhere else. We're not the authoritative source. Not many people actually publish solely to Conda-forge, right? And so this helps us keep up in a really critically important way. The other thing about the auto-tick bot, well, this tells you a tiny bit more about its history. It has submitted 20,000 PRs in the past year. Thank you, Conda-forge bot. The Conda-forge bot has also been essential lately because we've undertaken these projects that require us to rebuild massive trees of things. And so the very first migration, they call it, was to use the new Anaconda compilers. And the key thing there is you've got to build everything, but you also have to build it in order. And the bot is awesome because it's graph aware, and it will submit PRs only when the ones that it depends on have been merged. And it's just awesome. So anyway, that's what a Conda-forge migration looks like. This was the OpenSSL update. We are in a little bit of a transition, getting the community off of OpenSSL 1.0.2, which will go end of life at the end of this year, to 1.1.1. And this is the bot in action. Skip that. So I mentioned Conda-build 3 and the Anaconda compilers. A lot of what I talked about better constraints has come about thanks to Conda-build 3 and Conda-forge's use of it. What Conda-build 3 really introduced was a much better way to have pinnings be dynamically generated. And so this made everybody's lives easier. They just kind of specify a central pinning file, and that's very easy to update. You don't have to go through all your recipes and change pinnings. And so this has helped us have more robust, better pinning information. As far as using the compilers, this is true for certainly on Mac and on Linux. This has greatly improved the binary compatibility with the Anaconda distribution itself. And so the odds of like a mix of defaults and Conda-forge packages, they work much better than they used to. Thank you, Conda-forge. Yeah. As far as Conda metachannel, this is like, it's a really cool project because it's visionary. It's visionary because we have a problem in that our metadata is ever increasing, right? And that means that Conda is always going to get slower. That's not cool, right? How can we fix that? The answer is you don't load all the repo data all the time. You come up with ways on the server side to only pull down what you need. And what metachannel does is it takes the repo data information from all the channels that you've asked for and also potentially specs that you specify, and it returns a reduced repo data.json to you totally transparently that's vastly simplified. So it's a very, very powerful tool. You can see here its net effect in metadata load time for nothing being cached. It goes down to just about as fast as nothing but defaults. So very cool project. So let's shift a tiny bit and talk about what you can expect to see in the near future, and then we'll talk about what's a tiny bit further down. We've been spending more time on performance improvements. We have a new package format to tell you about. We're going to remove the old free channel. I'll tell you more about what the old free channel is. And we're also going to turn on strict channel priority by default. We're working on repo data signing, and we're going to improve unsatisfiable environment messages. So why on earth would you ever invent a new file format? It's a good question to ask yourself. We thought about it, and we do think it's worthwhile. These were our goals. We really want to use new compression formats, and they're not commonly available yet in say, like a tarball format. We don't want to be affected in the future if we want to change that compression format. We want it to be kind of hidden so that we can change like the internal implementation without requiring a brand new container. We want to support package signing without having extra files to keep track of along the side. We potentially want to allow modification of metadata without altering some reference checksum. So right now you have a .tar.bz2, and if that package's like dependencies are wrong, which happens pretty often. And right now we do kind of a metadata hotfix on the repo, but when people pull in those packages and they build their own index locally, they don't have that hotfix and they're toast, it's broken. So we can potentially fix things in the package, but if we do that, we change the hash of that package, and then people are confused as to why hashes change. So we kind of wanted the potential to be able to change metadata without altering some key reference there. We also really wanted to be able to read the metadata without extracting the package. So this gets back to something like large packages like MKL that take 40 seconds to extract a .tar.bz2. We would really like to be able to read the metadata from that package much, much faster than extracting 40 seconds of a .tar.bz2. So this is the format that we ended up with, the .conda format. We have just a trivially simple JSON file info describing like the version of the file format itself. It doesn't contain any metadata for the package. Any of the other metadata is going to be in that info container. We can have an arbitrary number of, say, signature files that ride inside that container. And then the reference, the key guts of the package are that PKG thing. That's the authoritative thing that does not change. Everything else, yeah, pretty volatile. You may sign it and add more signatures to it, but it doesn't change the core of the package. All right, does it work? Yeah, it works pretty well, actually. So we have a bunch of kind of prototype stuff. We actually split Conda's package handling out into a separate library because it was kind of duplicated between Conda and Conda-build. So there's this new Conda package handling library you can play with. And you can look at, we get a benefit both in terms of the size of packages and a dramatic increase in performance for decompression and extraction time. So we're really excited about this. Conda-forge will totally use this transparently. And then I can talk to any of you who are interested in learning how to use this yourself. It's a little bit more complicated. So the free channel. Let's first talk about what defaults is. Defaults is a metachannel, and that's not the same thing as Conda metachannel, the Conda-forge project. It's a different beast. A metachannel is a channel composed of other channels. And defaults is composed of main, free, R, and MSys2. And those are all channels that live on repo.anaconda.com. The free channel was all of our software that came before the Anaconda distribution 5.0 release when we switched to the new compilers. So that's the key difference. The other thing is it didn't use Conda-build 3, and so the constraints were done more manually. And here's a comparison of constraints between free and main. And just to give you guys an idea of how these might cause problems, you see on the right with the main channel, you have a lower bound and an upper bound, right? The lower bound correspondingly in the free channel is a lot more relaxed and is going to bring in stuff that potentially could cause problems. And so the automated pinning has given us this better way of kind of having an advancing front of compatibility that ends up reducing your package space quite a lot over time and makes things easier to install. We also expect a bit of a speed up because the free channel is currently about half of what we provide in that defaults channel. So, but this isn't something we should take lightly. We're removing content, right? Except we're not going to remove it. It's still going to be there. It's just not going to be in defaults. And we're going to work really hard to give people good ways, if they still need to use it, to enable it. It's a tiny bit tricky just because channel priority, right? You can't just re-add this, because if you re-added it, it would actually be at the top of your channel priority, and then you'd get it preferentially rather than lower. So we're hopeful that pulling this out of the system will not only make things a lot faster, it'll also take out a lot of the confusion that we see where things take hours because those broad pinnings just allow strange solutions that are not really actually solutions. Strict channel priority by default. We talked about the benefits for this. We think it's going to reduce a lot of problems. The problem with doing this is that strict channel priority leads to a ton more error messages about unsatisfiable errors. And it does this because Conda previously was able to just say, oh yeah, this might work, and bring it in. And would it actually work? Maybe, sometimes. But the point is, Conda's unsatisfiable error messages aren't very good at the moment. And that's kind of like what I'm saying is a blocker to implementing strict channel priority by default. So we will implement it. Those two are intricately tied. What should it say? Something that people can understand, hopefully. So we'll play with that, and hopefully you guys may engage with us on our issue board to help us understand what is understandable. People talk about package signing and repo data signing, and I guess what I want to distinguish is that they have very different purposes. And for the purpose of preventing a man-in-the-middle attack, repo data signing is great. It is to say, even with HTTPS, you can spoof it, and there's this great link at Cloudflare about that. What signing is going to help you have confidence in is that software came from the channel that you added. You can check that against the public key that's provided by that person. And the reason why we're going to start out with signing the repo data and not go straight to signing packages, well, first of all, it's easy. And second of all, it's also like sufficient for a lot of the use cases. So when you sign just the index, you are also implicitly signing the packages, because the index contains secure checksums of the packages. So this is kind of a key assumption that we were happy to discover that the Linux distributions do, and we're going to have this out pretty soon. So a bit further out, I've talked to several people at the conference today and through the week about what is slow. And what is the most slow to people is the incremental stuff. You have a Conda environment, you want to modify it. That is way too slow. And I think one thing that we can try to do to improve that is to say, we already had a solution, let's work off of that old solution to get there. This is something that we need to do some learning about, so it's going to be a little bit further out, but definitely very high priority for us to make this faster. We will implement package signing and some kind of a scheme for like better repo verification, like tough or something like that. We're not looking to reinvent the wheel. It will be some well-established cryptographic standard. We're also going to improve environment spec files and lock files. So a lot of people say Conda can't do things like pip-env. We're looking to satisfy that and go beyond it. We're also looking to make spec files cross platforms. And so right now it's kind of annoying because you bake a spec file and it's specific to, say, OS X or Linux or whatever. So we're looking to give you all the convenience, but also the flexibility to go across platforms. Finally, I think one thing that's really important for us to consider as a community is what is the permanence expectation of any channel that you manage? And so we've talked about this in the context of Conda-forge. They want to be able to remove packages from their main channel over time. But if you've baked an environment file that references main, your environment file will be broken. So we're going to have to set out standards for what is a truly permanent channel and how do you distinguish like the permanent channel where things are going to be slow relative to the main channel where things are going to be fast and convenient. So that's part of this thing. And finally, I'd like to thank my team. These guys are great, and thank you for listening.